All right, we're on to lesson 7 notes. We're going to talk about exponential regression today. This is the last topic of this unit, so it's exciting. Okay, exponential regression. The point in collecting data and plotting the collected values is usually to find a formula that can be used to model a relationship. The process of taking data points and coming up with an equation is called regression, and the graph of a regression equation is called the regression line, which represents the line of best fit. So basically, if you're a scientist or something and you're calculating a bunch of data, what you can do is you can plot all those data points and then figure out an equation that best represents that line. Once you have an equation, you can make predictions, you can find out other information, make very valuable guesses about something based on that equation. So we'll talk about the next part in a little bit, about the r-squared value. Basically, when you come up with an equation, it's not going to exactly match your data points, but it's going to be very, very close to it. So we can figure out an r-squared value. It's called the coefficient of determination, and it tells you how close your equation is to modeling those data points. So if you have something like a 99% r-squared value, or 0.99, that means it almost exactly matches your data points, so you know it's very accurate. If it's something like 0.85, it maybe isn't as accurate as you'd like, but it could still give you some information. So the thing is, we have to figure out what kind of regression we want. So you have to decide, is it linear? Does it look like a straight line? Does it look like an exponential function? Later on when we talk about logarithmic functions, does it take that shape? Because that's going to determine what kind of equation you use, whether you use a logarithmic equation, exponential equation, linear, quadratic, that kind of thing. So if I had some data, it shows on the scatter plot some different bits of data that I've plotted from some experiment or some piece of research. I want to know which would be the best fit for an exponential equation. So if I draw my line of best fit, for the first one, it's going to look something like this. We know what an exponential function should look like, right? An exponential equation is either going to look like this, or it's going to be the opposite, and it's going to look like this. So the first one is not an exponential function. It's actually logarithmic, which you're going to get into in the next unit. The next one here, if I look at it, if I draw a line of best fit, it's going to look something like this. That is also not exponential. This is more fitting for a linear regression. If I do the next one, you can see it starts with a bit of a curve and then it grows faster. This is what an exponential function looks like. So this would be an example of an exponential equation. And then for number 4, you can see a line of best fit. If I was to make an equation for it, it might be something like that, which again is a linear example. So number 3 is our best fit for exponential growth. So if I plotted my data, I'd probably try to use an exponential equation with it. So all of the ones we're going to do today are for exponential functions or exponential equations. Once we learn more stuff in later units, then you're going to have to kind of decide what is the best one to use. So let's look at example 1. A lot of this is a lot of calculator work, so I definitely recommend pausing my video every so often, typing it in yourself and making sure it works on your calculator. And again, the older versions of the graphing calculator are slightly different. They're basically the same, but I'll kind of explain it as I go. Before you do anything though, we want to turn your diagnostics on your calculator, because this is going to give you your r-squared value to tell you how close your data fits your equation line. If you notice also, I posted a document that has all the calculator keys laid out for you. So I'm going to show you one here as well in the video, but if you need a reminder, you can look at that calculator keys page and it will tell you what buttons to push. Once you turn your diagnostics on, it's going to stay on forever unless they clear your calculator or you get a new one. So for a calculator, if you want to turn your diagnostics on, you're going to hit second, then catalog, which is down at the bottom, and you're going to scroll all the way down until you get to diagnostics. So you get to watch me do this for a little bit. Diagnostics. Almost there. Okay. And then you're going to go to diagnostics on and hit enter. And then you're going to hit enter. And then it's just going to be on. And then when we calculate our data, it's automatically going to pop up for us, which will be nice. Okay. So now let's go back to our original question. And I tried to write most of this down in the photocopied copy of the notes as well so that you kind of know what to push as well. Here is our data. So rabbits were accidentally introduced to an island where their population is now growing rapidly. Biologists studying the rabbits have periodically recorded their population since they were introduced to the island, and here's the data. So what we can do is we can enter this into our calculator. Our x values are always in our list 1, and our y values are always going to be in our list 2. So you're going to go to your calculator, and there's a button that says Stat. You're going to click on it, and then click the button that says Edit. I'm going to show that as well. That's written down in your notes so you know where to go. And this is how we're going to enter it into our calculator. So we're going to go to the Stat button and hit Enter on Edit. Oh, I already have some stuff in my list, so I better clear those off. To clear your list, you can just scroll up to the top, highlight the top, hit Clear, and then Enter, and it clears the whole list. Okay, so my first list one is going to be my x values, which we figured out was 2, 5, 7, 11, and 15. So you're going to enter all those in. Be careful here, because if you enter in something wrong, it's going to throw off all your data. So you have to kind of precisely enter in all that data points. For list 2, it's all your y values. So we have 75, 100, 112, 205, and 290. Now everything is entered into our lists. Okay. We want to be able to produce an exponential regression equation from this. We know already, they tell us it's an exponential regression. So now we have to go in and actually figure out what is my equation for it. Okay. So this is where you're going to enter in. You're going to go back into your Stat menu. And now we're going to move over to Calc. And now you have to move down until you see it say Exponential Regression. It's the 10th one down, so it's off the screen here. You're going to go down here until it says Exponential Regression, and you're going to hit Enter. If you have a newer calculator, this is what it's going to look like. If you have an older calculator, it's not going to look like this exactly. What you want to do for a newer calculator before we move on, if you hit Enter, it will give you your equation, but we want to do something else in this process as well. We want to store our equation. What this is going to do is it's going to store the equation exactly into our y equals. So when we graph it, we don't even have to type anything in. And this is important because otherwise I'm going to be rounding my values and typing it into my y1 to graph it up here, which will then be slightly off because I've rounded my values. When you store it, it's exactly the exact equation and it automatically populates into your y1. So it's an extra step we're going to do now, so I don't have to go back into this. So what you're going to do is you're going to hit the bars button. You're going to move over to y bars and then hit Enter, Enter, until it says a y1 right here. That's for your new calculator. If you're on the older version of the calculator, you don't quite get this full screen. I can't remember exactly what comes up, but before you hit Enter, you can just do the exact same step, and whatever you have written here, you're going to go to bars, move over to y bars, hit Enter, Enter, and then it'll say that same thing but y1. And then you can hit Enter and it'll also store in your calculator. So try it out, pause, try it out, and definitely this is the place to come meet me on Google Meet if you're stuck, because I can bring my calculator up on the screen and show you, or email me or whatever and I'll explain it. Okay, now we're going to move down to calculate. And now it gives us our equation. So it's nice because it gives us the setup of the equation here, so I know where to put my values, and then it tells me what my A value is and what my B value is. And then I can just substitute it back into that equation that they put at the top. It also tells me my R squared value, so I can see that my data, my equation that I made, matches my data points to about 98.6%, which is pretty accurate. Okay, so now that I have that information here, that's going to answer my first question. It says determine the exponential regression equation that models that data, round to the nearest 100. So I'm going to rewrite it out. That A value was, I rounded, 58.2. Let me just check that out. 58.19 is what it should say. So I think that's a little mistake on my notes because I rounded it to the 10th. And then your B value was 1.11. So this is my exponential regression equation. And it also wants me to determine the value of r squared, the coefficient of determination. And that automatically pops up because you turn those diagnostics on. So I know this models it pretty accurately. Okay, then purpose is just graph this equation using your calculator for x between 0 and 20. That's helping you set your window settings. So when I go into my calculator, under window, I know I want my x to be between 0 and 20. So I'm going to change my min to 0, my max to 20. I'm just going to make sure everything else is standard, because I was messing around with it earlier. Okay, then you're going to graph it. And now you can see what the equation looks like. Then we can continue on and answer the rest of our questions. So let's go to part C. It says, based on your model, by what percent is the rabbit population growing each year? So I basically want to know how much it's doubling or tripling, or is it increasing by 1.5 times each time? What you're going to get your answer from is from your b value in the equation. So my b value in my equation, anytime it says what's it increasing by, what's it decreasing by, you're going to be looking at your b value, which remember is this guy right here. So my b value is 1.11, and I want to know what percent is it growing each year. This is the same as 111%, but remember we're comparing to the regular population, which we started with 100% of the rabbits. Now we're at 111% of the rabbits. So minus off that 100, and you're going to see that the rabbits are increasing by 11% each year. So it's always from your b value. You're either always, well not always, but usually you're going to be either minusing 100% or adding 100%, or minusing it from 100%. Okay. It says graphically determine the population of rabbits 3.5 years after being introduced. So all these questions, we're going to kind of look back at our chart. We want to know what the population was at when we had 3.5 years since introduction. So in other words, it's telling me my x value is 3.5, and I want to know what my y value will be. So it's telling me my x equals 3.5. I now want to determine what my y value is, because that's going to be my population. So we can use our calculator to figure that out. And I wrote it off to the side here. If you go to your calc menu and then value, you can enter in any value for x and it'll automatically just tell you what the y is. So let's do that. So I'm going to go second calc, and I'm going to go to value, which is number 1. And I want to know when x is 3.5, I'm going to hit enter, and it'll now tell me what my y value is when x equals 3.5. So I can see it's going to be, if I round to the nearest rabbit, 85 rabbits approximately would be there after 3.5 years. I don't know why I'm using red, just for fun, I guess. Okay, next question. It says graphically determine to the nearest tenth of a year when the rabbit population will reach 350. So if I look back here, I want to know when the rabbit population is going to reach 350. So that means I want to figure out what this value is, my x value. It tells me my y. I want to know my x. The y value is not as easy. There's not an exact button to push, but there's a way around it that we can figure it out. So it's telling me that my y value is 350. I want to know what is my x. Okay, so what you have to do is you are going to graph the y2 in your calculator is 350, and you're going to see where it equals your graph, and the x value there will be your solution. So whenever you're trying to find your x value, you're going to graph that y value in your calculator. So I'm going to do that now. So y equals, notice how, oops, I've got extra stuff in here. That first equation has been automatically stored, not rounded, because of what we entered in there. Now my y2, I'm going to put as 350. Knowing that my y value is 350, I know I'm going to have to go into my window, and my y max is going to have to be at least, I don't know, let's say 400. in order to see it. And I'd like to change my scale too so there's not so many ticks, but it's up to you. You're going to have to play around with it a little bit. And then we can graph that, and then we're going to find their point of intersection, and whatever the x value is there is our solution. So now I'm going to go into second calc, go down to intersect. You can hit enter for your first curve, enter for your second curve, and then make sure you make a good guess. If it's too far away, your calculator will time out and it won't give you an answer. Okay, so I can see the point of intersection is 16.631, etc., 350. So here, oh, I'm just grabbing the wrong marker all the time. That's all good. Calc intersect, and you're going to find your point of intersection. And whatever your x value is here is your solution. And it's in here. So I can see after 16.6 years, we should have approximately 350 rabbits. And I like to look at the chart again and make sure that's reasonable. It doesn't seem to make sense that this would be about 16.6. Yeah, it follows about the pattern, so it seems reasonable. So these are basically the things you're going to do and the main steps you're going to use. So if you're ever given an x looking for a y, you're going to use that calc value button. If you're ever given the y and you're trying to find the x, you're going to have to graph that and find the point of intersection to figure that out. Okay, let's do one more, and then I'll leave the last one for you just to try and make sure it matches up on your calculator. So here, population of Jamestown has been recorded for selected years since 2000. So it tells the population over those years. We want to use our calculator to determine the line of best fit exponential equation, where x represents the number of years since 2000. So that's telling you that in your calculator, just to make it easier with Windows and everything, instead of using the year 2002 here, I'm going to use 2, because that's 2 years since 2000. Here I'm going to use 4, 5, 7, and 9. Based on what it says here, if it didn't say that, I could use my regular years and it still work fine, but it specifically says it represents the number of years since 2000. So we're going to rewrite it this way. This, we're going to enter in your L1 and L2. So we'll do that real quick. You can suffer through me typing it in again. So you're going to go to Stat, Edit, and again, you're probably going to have old stuff in there. So go back to the top, highlight it, hit Clear, then Enter, and it'll clear out your list. Okay, so for L1, it's 2, 4, 5, 7, and 9. And for L2, it's 5,564, 6121, 6300, 6812, and 7422. Hopefully I answered those all in good. Now we want to come up with the equation again. All the ones we're doing today are exponential, so we're going to go back into Stat, move over to Calc, move down to Exponential, hit Enter, and then again, if you have an older calculator, your screen looks blank. I think it might just say Calculate or something like that. Don't hit anything yet. For you, new calculators, we're going to go down to the Store, and then both of you, all of you, are going to go into Vars, Y Vars, Enter, Enter, to store it into our graphing screen. And then you're going to hit Calculate. Okay, from here, we're rounding A to the nearest integer and B to the nearest 1,000. Oh, the other one I was correct with how I had it. Anyway, it's all good. So we're going to write that down. There we go. It doesn't ask for our squared value, but it's there if we needed it. This part's done. Now we're going to graph it for the years 2000 to 2050. So in other words, I want my x to be between 0 and 50 on my calculator. So we're going to go back up to here. It should be stored in my y, which it is. Great. It's the unrounded version. My window, I want my x to be between 0 and 50. I might make my scale 5 just so there's not so many ticks. I want to change my y max back to what it was originally. Oh, maybe I did need more. Oh yeah, it needs to be much more. Okay, so Window, you can't see anything here. It's because my Y is too small. Oh, and also my scale is messed up. That's why. So let's do like 10,000. See if it'll show up here. Oh, we got a little bit of it there. Okay, so there's my graph. So let's go to part C. It says, by what percent does your exponential model predict the population is increasing per year? So if it's ever asking how much it's increasing or decreasing, we're looking at our B value, which is 1.041. If I wrote that as a percent, it'd be 104.1%. But again, you're comparing it to the original population, which was at 100%, so you're going to minus that off. And see that it's increasing by 4.1%. Approximately each year. And it says use your graphing calculator to determine the population in the year 2006. So it's telling me my X is 6 years since the year 2000, and I want to find my Y. So this is the nice one where you can type it in using that value button. So we're going to go into second calc, go to value, and we want to know when X equals 6, what my Y will be. I can see my Y will be 6,570 people. Make sure you include units or little bits of extra information as it comes. Okay, and then part E says use your graphing calculator to determine the number of years to the nearest year when the population will reach 20,000. So it's telling me my Y is 20,000, and I want to find my X. So you're going to plot that 20,000 on your calculator and find your point of intersection to solve. So back on my calculator, my Y2 I'm going to put as 20,000. I check my window. I know it needs to be at least at 20,000 for my Y values. So let's change this to, I don't know, 30,000. And then graph. There you can see your point of intersection. So we're going to go second calc, down to intersect, enter, 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 make a good guess. Enter, and you can see your point of intersection there, 33.598, etc. And then your X value is always your solution. It says to the nearest year, so I'm going to round that to 34 years. So after 34 years, I should expect the population to get close to 20,000. So you can see regression is super handy in real life. If you do any type of research, scientific type research, or gathering data, then it can become really useful. Example 3, just try on your own with your calculator, make sure you get the same values, and please reach out if you can't figure out the calculator part. That's pretty much what most of this is. So if you got the calculator down, you should be good with this topic. Have a great day.